morning. Can you hear me? OK. Thanks for coming. I'm going to tell you the story about VLC, which is a bit of an unusual story. So I'm a geek. I'm 38 years old. I'm French. And I've been coding since I'm 15. And I've been spending the last 15 years working on open source video technologies that you're using every day. Even if you don't use VLC directly, everything that you're using today online has been modified or worked on with VLC and the VideoLAN nonprofit. So the story of VideoLAN is a weird story because it was never designed to be what it is. It was a student project that was started at the École Centrale Paris around 25 years ago. So 25 years ago, the campus that you can see here is managed by the students. So it's very unusual for any university or French company, university, that everything on the campus is managed by the students, right? And because of that, the network is also managed by the students. And in the late 80s, they installed something called token ring. Probably none of you know what technology it is. But token ring is a type of network there. Every computer talks to the next one, right? In a kind of ring, instead of having like routers that makes everything connect, which is very cheap, but very, very slow, right? Because every packet has to go from one computer to another. Every computer checks it and look at what's in and say, well, this is for me or this isn't for me. So in 1993, they want to play video games, right? On the campus, and of course, when you have a token ring network, the latency is quite high, right? So when you start playing Doom and Quake, what happens is that, well, you have high latency, well, you die, right? You get fragged. So the students want a better network in order to play video games, right? So they go to the university, which is over there at the top, and they say, well, you know what? We want to have like a new network. And the university says, yeah, you want a new network to work, so there is no way that we are going to allow you and buy you a new network, right? So they go and they scratch their head, and they go to see a lot of partners, right, like sponsors, and they go to Bouygues, which is the one who built all those pieces of concrete that is a university. And Bouygues is now trying to work with TF1, one of the main French broadcasters, and they say the future of video is satellites. Of course, today it's not. Well, you know that. But in 1995, that was a good bet, right? And they say instead of buying those satellite decoders, which are costing around 2,000 francs and big dishes for around 2,000 students, which would spend millions, they say, well, we're going to buy you only one dish, and you're going to take all the data, which is digital, and send that to the network. So today it's obvious, but we're 12 to 15 years before YouTube. And it sounds crazy because those computers are 4086 at 33 megahertz, and there is no way that a normal computer can decode video in real time. But they want their new network, so they do it, right? And that's how the VideoLAN project starts. There is no question of being open source. There is no question of VLC. It's just like, let's do a demo to justify to buy a new network. And the guy says, OK, we pay for that demo, right? And they spend around 1 million francs of networking environment, and they got their new demo. It worked great. It crashed after 35 seconds, but you don't care, right? The demo was there. And the project could have stopped there. But a few students, 1 year after, in 1998, says, well, you know what? Maybe those technologies can be used outside of the École Centrale Paris and can be useful. And that's how VideoLAN became. So VideoLAN is doing a lot of other technologies and software. Most of you don't know them, but you're using them every day. Every day you go and watch on YouTube, on Netflix, on any basically video online, you're using some piece of the technologies that has been developed by VideoLAN. One of them, of course, is VLC, but there is a lot of decoders, encoders, especially the encoder called X264. And if you've ever downloaded something illegally, you probably know about it. If not, you might lie. Anyway, so the idea of VideoLAN, and that's a slide from 2002, was to be able to stream anything on a network. And there was everything related to server, to encoders, to, at the end, the VLC that is just playing back. And 20 years after, it still works. So what happened is that the project, which was VideoLAN, had the client software called VideoLAN client. And VideoLAN client, which became VLC, was not open source at that time, right? 1999, it wasn't. It took them 2 years to convince the university that it was a good idea to make that open source. But the university wanted to make money out of that, and the students said, well, no way, we cannot do that. So they start this software, and they just publish it, right? And for some weird reason, 2 students from outside university port it on Windows, and another one on macOS. Because at the beginning, of course, it was a Linux-only software. And the people from the École Centrale Paris, the students, had like no idea and said that it was useless to port on Windows. And of course, the student who was on a different university who ported on Windows made it so popular. And of course, at that time, the software was not finished, and there was this weird code saying, well, this is not finished. And this is completely idiotic, right? Like, who would use a cone for a player, a video player software? It makes no sense, right? Like, but yet, it's completely magical and a very good marketing opportunity because it's so weird that people know about it. When I move and I say, well, I'm working on VLC, many people just, well, what is VLC? And when you say, yeah, the cone that you have on your computer that plays videos, and they're just like, yeah, I know that, I know that. Of course, it was not like a plan, right? It was just like a bunch of students who were hacking on things and made it like that. So we're talking about around 1 million downloads per day of VLC. We are talking about around 500 million monthly active users. And on our website, there was more like 3.8 billion downloads. This is probably one of the most used software on all platforms. On Windows, it's on the top 10 used software. On macOS, it was around the same. But it's even used more, because many of the applications you have on your phone or on your TVs are using VLC behind and just the technology. It's weird, especially because it was a student project done by people who were probably younger than most of you, and were just hacking on some things. There was no, people were, it's fully open source, people were working without a plan, without marketing, without Scrum Master or product owner and POs and PMs and so on, just people working on something because it was cool. So why became it was very popular? In 2001 to 2005, if you were downloading things illegally, which none of you would do, right? Because that's very, very bad of you. It was a nightmare, right? Like you downloaded a file, a video file, you couldn't open it, right? So you had like to download codec packs, which were a nightmare, and you downloaded codec packs, and then it didn't work. So you downloaded another codec pack, and it was fighting the first one. So the only thing that you got was viruses and adware, and you could reinstall your machine. VLC doesn't work like that because it's a Linux software ported on Windows. So with VLC arrived the whole packages of the codecs. So in very early, VLC was the best way to play anything, right? You can send very weird video files, and it still works. And we'll see technically, because there are technical reasons why this became, and there are good reasons why it became like that. So it played everything, any stupid thing, many formats that you've never known, and it worked everywhere. For a long time, VLC was the only way that you could play a DVD on macOS 10 because Apple didn't license the software. We work, of course, on all mobile devices. We still work on OS 2, which is probably used by 5 people on Earth, and one of them is the maintainer of VLC on OS 2. It is ridiculous, yet the way that we structure VLC makes that maintaining different ports doesn't cost us anything, or is not a problem at all. And that is extremely important, because the way that we've developed VLC and designed VLC made us very resilient to software rot. So as I said, we are very much open source, and I mean, like, by open source, I mean free software in the hippie way, right? Not in the Google Android way, something like actual open source with teams who were volunteers and working on their free time to make freedom for the users. So it was, of course, started in the late 90s, like many other open source software like PHP or Apache or Linux, but it was exactly in those same ideas to do the same for multimedia. Most of the guys that you're seeing are students, right? Like, those are people who worked on their free time. And I started VLC when I was at the university, and many other generation. And every year, a new group of students came at the university, started working on them, and so from late 90s to mid 2000, it was developed like that. And after that, it became like older students and young professionals who were working on their free time at night, on their holidays, working on VLC. Today it's very weird, right? Because like people, when they have free time, they're going to do a new side project that is going to be the next Uber for tombstones or a connected shoelaces or something like that, right? And working on your free time for an open source project is something that people don't do that much, right? Especially because the open source now is big companies from the US, from the Silicon Valley who are doing that. And it has open source just the name and the source, but not the philosophy behind. So I'm going to show you a few demos of very old version of VLC. This one is, as you can still see, it's VideoLAN client, right, the original name of the software. We removed the client name because it's also a server now. Anyone knows what movie that is? Yeah, James Bond, of course. Which one? Not gonna lie. Tomorrow Never Dies. It's important for us because all the first DVD that was played on VLC was GoldenEye. And so all the code names and all the machines of the servers that we have are based on characters from James Bond. And as you can see, those were very old Linux versions. That was the first one that was being able to play directly TV feeds. The first version of macOS with this Aqua look that is very outdated those days. And probably the version that most of you know, which was based on WX widgets, which is a terrible widget library. Don't use that ever. And that was from 0.7 to 0.9 versions of VLC, so that's 2003 to 2006. And soon then we moved to the second Mac version, which was a bit nicer. And then we moved to Qt, which is a version that we still use today, which is based on Qt 4. And of course, that's the best version because it plays ponies, right? But yeah, so VLC evolved and has been evolving all the time. Most of the time, you don't see it because supposedly you don't see VLC. You double-click on a file, it just works. And that's the goal, right? Because the best UI is a UI that you don't see. But all that is maintained by VideoLAN, which is a non-profit organization that I created in 2008 after the time from the university. Because at some point, the university couldn't keep up, right? The downloading of VLC became too big. When we were doing releases, we were talking about around 10 gigabits per second of uplink. We were destroying the university network. And also, the software became too complex to maintain. Because, of course, at the beginning, you add the cool new features, right? But then you need to maintain them, and it's more difficult. So we had to use more professional than just students. So that's how the VideoLAN Foundation was created and that I started. It's a non-profit, Loi 1900, French one, extremely simple. There is no member fee. The members are around 30 to 40 people. They are usually the core VLC developers. But they're also the FFmpeg or the x264 developers, so other open source community on multimedia are part of that. It has no income, or almost no income except donations. And with donation, we basically pay for servers. We buy hardware, a lot of graphic cards, because that's very expensive to buy. And basically, we organize conferences and ship the people. But it means that the VideoLAN nonprofit is worth a lot because it owns the trademark and the website, but it doesn't employ anyone, right? People who work there are just like doing it for free. And that's very good because that means that we are very resilient, right? If we have no donations anymore, well, VLC could stay around, right? It's not like if one company stops, then there is no one left. How do we work together? So like we moved to Git before GitHub existed. So we were one of the earliest adopters to move to Git. We use only open source software on our servers. That means Track and PHPBB. We use IRC, you know, Slack for old guys, on command lines for most of us. Like Slack didn't invent anything, right? Like all that were still how we worked. And of course, because no one was paid and people were around the world, like, oh, we're going remote. Well, we were remote anyway. We have very simple rules of collaborations. that I'm going to detail a bit. So the hosting that we had on VideoLAN is, of course, the mailing list, everything related to the Git and the Git UI, of course, everything related to a CI, the wiki, the patchwork, and so on. And so over the year, we developed and pushed a lot of services that, of course, we were hosting ourselves, right? Because there is no way that we're using some third-party SaaS because, well, you don't know what's running there, right? So yes, we are a bit paranoid. But if we don't use only open source software, that when we are developing open source software, then like, how do you make the thing advance? So this is changing now. We are moving everything to GitLab, of course, hosted by ourselves using the free version, of course. But the thing is, like, they were starting to have too many tools. So we are just like maintaining one tool for the development. And you're seeing that lately. Like, there is so many new dev tools around, but it's a bit tricky to use because there are too many of those, right? And so we're regrouping everything to GitLab, and we're helping GitLab to add new features, like we were the one pushing a lot for the static analysis integration on GitLab and OS and fuzzing and so on, because that's needs that we have instead of using external services. For our users, we use just a forum and IRC, and that's mostly enough for most of our users, because even if we have hundreds of millions of users, we have very, very little questions about the software, because like people just works. And also, like, when it doesn't work, it's so complex to fix that basically just report bug. So how do we contribute, and how do we make decisions? It's extremely interesting to see that VLC is maintained by 5 persons. And it has always been like that. At some point, we were 2. In late 2007, we were 2 of us. And yet it still works, because a lot of the contribution are random developers that come and go. And because the software is very well developed and split, it's very easy to come and add a new feature. Because when you're adding a new feature, what you're adding is basically a new module, right? There is nothing very complex. So a lot of students arrive, do one filter, do a new codec, and then they go away. And this is one of the reasons why VLC basically won, while other software that were other media player were still existing, like MPlayer on Linux. And also, so we have around 150 people contributing every year to VLC, which is, of course, ridiculous compared to the Linux kernel, but compared to most other open source software, it's quite large, especially when none of them are getting paid. But how do we integrate the code, right? We integrate the code not based on the usability or the usefulness of your feature, but about maintainability of your code. Why? Because in 6 months, like statistically, you're gone, right? You're going to give me, oh, no, I'm going to be here in 6 months to maintain the code, right? But in 6 months, you change wife, you had a kid, you changed job, you had an accident, whatever, right? Like, statistically, we had around 1,000 people who contributed to VLC, and only 10 are left, right? So 1% of people stay, right? So I need to be able to maintain your code, so I'm going to be horribly annoying on your code contribution. So, and that's, like, the quality that we have on VLC is very annoying for a lot of users contributors who are used to do a pull request on GitHub and just, like, have 2 rounds and get in. In VLC, it can take 5, 10 rounds to get the code. But it's important because we know how to maintain it, right? And so the core, the complexity is on the core. It has a lot of abstraction to make it easier for developers to extend the software. And as I said, well, there is no marketing, there is no legal, there is no PR on VLC. People just use it, right? So it's very different from most of the software or the software that have like a product team that is defining, like a Scrum and so on. But it works because we're at the service of the users, and we are also the users of the software. So I was going to explain why we became popular. Like, there is 3 reasons. The first reason is that we have a very modular approach, which means that there is a very small core, around 100,000 lines of code, and then everything is a module, around 1 million lines of code of modules, but a lot of the modules use third-party libraries. So VLC, when you compile the whole VLC, you're compiling around 15 million lines of C and C++, and assembly, of course. But in the VLC code base, like, the complexity is on this very simple core. And users can come and not understand the core and just add a feature, add a module, and go away. So that's good for contribution. It's also good because that's the reasons why we can be on so many platforms, right? Because on one platform, you're just going to have a video output, an audio output, specific to your platform, and that's it, right? And the rest of the code, as long as you can compile C, just works. Which brings to my next remark. We are doing a kind of C++, which is a kind of, we're abusing pointer to structures and pointer to functions and common structures to do a very, very simple object layer. And that's a bit weird compared to lots of people who do in C++ or in Rust today. But it keeps the ABI very simple and the API very simple. And also, it's very easy to compile everywhere. Sure, today it's not a problem. In the 2000, having a C++ compiler on OS/2 on Haiku was tricky, right? There was difficult questions about ABI, about APIs, about integration. And because it's also a very simple language, with a lot of issues, of course, but it's a very simple language, and you don't fight to see what is the right version of C or the right version, like you could see on C++ or Rust, fighting over and over and over. And because the language is very simple, it's also very readable. So yeah, it means that handling strings is horrible, but this is quite good. And also manage, because the API for the modules are basically 3 functions for every module, it makes it very simple. This is a graph of basically how VLC works. It's like every other multimedia software. What is interesting is basically you have like a protocol handler that is basically HTTP or file, takes a URL in the beginning, gives you a stream, and then you have a format, which is MKV, MP4, AVI, that splits it into video codec and audio codec, and then filters it and outputs it to your eye and to your ears. Quite simple. The big difference with VLC is that those 2 arrows go on the other way, right? So when you went to, for example, for YouTube a long time ago, you were seeing that it was downloading as much as it could, right? And VLC, because it's a network and it's done for streaming, basically we only request what we're going to read. And because of that, VLC is extremely resilient. And for a long time, VLC was one of the, you were downloading something from eDonkey or Emule, which none of you did, of course, because that was extremely illegal, or BitTorrent. And like after 24 hours of using your DSL line and hoping that your mom would, or your 50K line, and you're hoping your mom would not start having a call because then it would drop your connection, you realize that the movie that you were downloading is absolutely not one, right? You were downloading a Disney, you got an adult movie, you were downloading an adult movie, you got a Disney. Anyway, it was very annoying. But VLC, because it's done on network, it expects the data to be corrupted. So VLC can play a lot of files that are completely broken that no one else can read, because VLC doesn't expect you to have the full file. And this is also one of the reasons why VLC became very popular. And it's because of this graph that is focused on using as little resources as it can, because it's a streaming player. So I'm going to show you a few completely stupid and completely useless features that you have in VLC that were basically because we can, right? All of those stuff are modules, right? So you don't know, but so this is a virtual box with a macOS machine, and this is VLC, because VLC by default has a VNC and remote desktop integrated. Yes, of course, like we can play video, we can play audio, we can have mouse clicks because we can support DVDs. So why not put a VNC? It's easy. The modules to do VNC is maybe 600 lines of C, something quite simple. We can do screen sharing, which is completely useless because there is so much better screen sharing program. But it's very cool because it can give you a good mise en abîme like that, and then you can post it on Reddit and get free karma. Cool. Well, internet points, that's important, no? Don't we leave all for that? For the French people who know Freebox for a long time, the Mosaic was one VLC that was doing it. And that's when you realize that VLC is not just a player, right? Because here it's playing back 20 streams at the same time and compositing them in terms of kind of picture-in-picture. If you've been to any bar with lots of big screens like that, most of the time it was just VLC playing one wall that was developed in 2002. This one is a tiny bit more complex, but not that much. We support karaoke and MIDI because there is a good reason for that, right? Probably some Asian guy. We have a puzzle module in VLC, so you can activate it. Actually, you can test it. You can actually click, and you click on the puzzle pieces, and you can move them around. It's very nice when you're playing a very French movie and you want to not get sleepy. Then you can like have a game at the same time. And one of the reasons, it's a math teacher in France who developed that because he wanted to explain to his students the Bezier curves and had like a good reasons to use that for the PCs and so on. And so we integrated that knowing that no one would ever use that, right? Like last year, I got an email from a guy saying, oh, well, you know, this puzzle is too simple because it can only go to 16 by 16 pieces, which is 256. Could you increase that? And I was just like, what the fuck? Are you actually using that? So like now you can go to 250 by 250, which is 65,000. When you have 100 million users, like everyone is using all your features. We have a console version, right? So you can, but from command line. And well, the problem is that if you do that and you control VLC from command line, you still have the video that is basically using a display, right? Well, no worry. We also have an output that is in ASCII art. And we're not even Unicode, right? This is ASCII art and playback of VLC. And you know what? It's used a lot, right? Because there is many cases where when you're on a router in the middle of a big network, a one network, and you want to know if the video is coming at that point of the network to debug it, right? And this is a good way to do that. Well, at least this is a way. We've had the version of VLC on Android, which is now quite popular. We probably have around 60 million active users on that. Well, it started with very old version of VLC, of course, and became more material and modern. We moved to Kotlin at some point. Very easy to move. And we have, of course, an Android version, an Android TV version, an Android Auto, and all that also is done in the open source way. We had a version on iOS, well, with this very old skeuomorphism that was popular on iOS a long time ago. Well, we moved to something more flat-like, of course. We have a version on the watch, because it's very useful to watch a movie on your watch. Of course, it's not on the store because it's forbidden by the App Store, because it's destroying your battery in a couple of minutes. Well, maybe a couple of minutes, but 20 minutes. Why did we do that? Because we could, I guess. Because it was fun, right? Like we are software developers, right? And working on some project like VLC is important because it's important to do cool things, right? And still have some fun and not just write yet another REST API to explain yet another endpoint for another boring use case. We have a version on Apple TVs. Just to give you a bit of numbers, a version like VLC 3, which took 2.5 years to get, is around 20,000 commits on the core and around 3,000 on each of the platforms, so 3,000 on Android and iOS. This one was a bit difficult to get because we were basically merging the mobile version with a desktop version, which was tricky to get right because the pipelines were not exactly the same. We had a version on Xbox One with a UWP. We are killing that one because it's useless. But it was interesting because it gave us some ideas that we are going to reuse in the future for the feature of VLC. We have a version for Tizen, which is, by the time it was out, Tizen was dead. Okay, why not? Of course, we have like lots of plugins for VR because it was cool to do VR 3 or 4 years ago. Now it's dead and it's going back soon. So maybe we're going to So this is an interesting one that I'm going to explain. As you can see on the screen, this is a Malayalam subtitles, because, of course, all of you can read Malayalam. And on this one, you can see of course, some Chinese, some Korean, and some Japanese there. Why am I showing you that? This was developed by a guy that I've never met who is in Aleppo, in Syria, and who, around 5 years ago, mailed me saying, hey, you know, I have around 2 hours of networking and electricity per day, and I cannot work because I'm in East Aleppo. Can I do something? I was just like, OK. Do you know C? No, I don't, but I'm going to learn. OK. And I say, well, can you speak Arabic, right? And he says, yes, of course. I say, well, we have some things that doesn't work in Arabic, because as you can see, like in Malayan, there is those kind of ligatures, right? You're used to French and English, where one characters gets you one design, but in Arabic and in many other languages, you have several letters, and they make one drawing, one glyph, right? So the guy arrives, and I said, well, I know that in some Arabic, we don't support well this glyph, so can you fix it? He says, yes. No news for 4 months. 4 months later, there is a patch on the mailing list that actually works. I was just like, oh, yeah, wow. We go back and forth, it gets mailed. And I'm just like, it says, give me more. I'm just like, OK. So I say, well, we have an issue with Hebrew. And I'm just like, guy, you're asking a guy in Syria, in Aleppo, in the middle of a war, from an Arabic country to fix something in Hebrew. Are you idiotic? I'm just like, sure. So the guy spent time learning how to design Hebrew and so on, and fix the Hebrew version. I was just like, OK. Of course, again, he sent the patch 4 months later. So then I'm asking, well, can you do the most difficult language on Earth, which is this one, because it's not just ligature, it's what we call complex text layout. And it's very difficult to do. They're on Windows, on macOS, on Linux. Usually there is a couple library who do that. No applications ever do that. But for VLC, which is cross-platform, we have to do that. And because we are not based on GTK or Qt for the core, well, we develop ourselves the same, right? And the guy just basically took 6 months. And at the end, I'm just like, OK, Salahuddin, what do you want? And he's just like, hey, you know what? Can I have an @videolan.org email and a letter of recommendation? Just like, yeah. So it's very, that shows that we can do great things, and students have been doing this software that is not done by marketing, not making any money, that is probably one of the most used software in the world, and just works. I'm going to speak a bit about VLC4, which is what we're working on now. So we are doing some changing on the UI, because people complain about the UI of VLC all the time. I don't care about the UI most of the time, because it should just go away and play, but people care. And we are basically improving the whole video infrastructure to consume less battery and less power, because power efficiency is a big topic those days. So this is what probably is going to be VLC4 on Windows and on Linux. So well, yeah, something that you would expect a bit more modern. It's a bit tricky because there is lots of function in VLC, so you need to still get them available to the end users. But so we cannot be as simple as YouTube or Netflix players, but we need to have something that actually works. Probably have a kind of optional media library to index your content, because one of the big fight that we are going to see is indexing content, right? So now the content is on a few platforms, YouTube, Twitch, and Spotify, and those platforms have very strong capabilities and I would say even blackmailing powers over content creators. So we start looking at how we can help disrupt a bit that by allowing other source of content. So we are doing things that can index what you have on your computer, on your home, or index what you have with your friends. So just to end, we're going to talk about 2 weird research projects. The first one is called VLC.js. Basically, we are going to compile the 15 million lines of C and C++ to JavaScript and WebAssembly so that you can run the whole VLC inside the web browser. It seems as insane as it is, because people have been using WebAssembly, especially people like Figma, but for very small parts, and I'm bringing a full desktop application over there. It works already, but it's not fast enough, because it's based on VLC. For the codecs, we have either hardware decoding, which is not available inside the web browser, or we write down assembly, right? VLC and FFmpeg have a lot of assembly directly inside the software, and it's handwritten assembly. But on the web, we cannot really do that in WebAssembly. So what we're working on is an assembly transpiler that is basically taking the ARM assembly that we wrote by hand and transpile that to WebAssembly SIMD so that we could use like the millions of lines of assembly that we wrote already to this weird WebAssembly format and get good performances. So it is tricky, but we're working on that. And the next other project is around security. When a software like Chrome or any software that is running on your machine crashes, it has basically admin rights, right? So it can read anything on your laptop and your desktop. So that's a very big technical problem, right? Because we know today how to exploit any security issue quite well. So one of the ways, the Android and iOS way, which is to put a big sandbox and then give you some rights, right? So you can access to audio, microphone, and so on, right? You've seen all those on Android and iOS. Things that no one reads anyway because you click next, next, next to install it. But anyway, supposedly you're looking at them. The problem is for VLC, you need to have basically all the permissions, right? In order to output video, I need to have access to your X servers on Linux, which means I'm root if I crash. On Windows, it's called DWM, which is kernel mode. I'm compiling shaders that come from files. So I'm taking some shaders from files, and I read them, and I compile them on your graphic card driver, NVIDIA, which is crashing all the time because no one updates their video drivers except gamers, etc., etc. So the problem is, if we do that for VLC, I'm going to have all the rights except the GPS. I don't know why I would use GPS in VLC, but next time we meet, I'm sure I will find a good reasons to use that. So basically, I have a sandbox, and I put the holes everywhere. So basically, I did not fix the thing. So one of the ideas is to split VLC into a type of 5 to 10 processes that have different security layers on all the processes. And that is basically what Chrome has been doing for their Chrome browser. But what they're passing is 5 megabytes of HTML and CSS and JavaScript, right? We're talking about hundreds of megabits per second of video streams, and you need to be able to scale that and have IPC with 0 copies on desktop and multiple platforms. So it's a tricky project, and it's one that we are going to work on. And finally, I want to speak about something that we're doing right now, which is the video codecs are heavily patented, and it costs a lot of money to have all those. So a few years ago, after VP9 codec was out, Microsoft, Google, Netflix, Facebook bound together to create this format called AV1 that is now basically the default on a lot of websites, and that is replacing the H.264 codec that we've been using for the last 15 years. But this one is patent-free, well, at least royalty-free, and we've been working on that with YouTube and Netflix to get there. But mostly what we've developed is an AV1 decoder, which is David. And David is a VideoLAN project, not part of VLC. It's written in C. We're talking about 30,000 lines of C. But we've rewritten most of the C functions in assembly. So now we are talking about 150,000 lines of handwritten assembly. And yes, this is handwritten because we are faster than compilers by a factor around 4. So like usually you say, yeah, but you shouldn't optimize because your compiler is clever. This is true, except for multimedia, right? We get 4 times faster, basically. But 150,000 lines of handwritten assembly, which is around 30,000 per platform, is huge. And this is what you have inside Chrome, inside Firefox, inside of Edge, of course. On the Windows store, the Microsoft AV1 decoder is this one. And all that is done as an open source project next to VLC. And of course, in many of your mobile apps, whether it's Android or iOS, like Netflix or Facebook apps, basically this is what it is. And still, it's done by the developers of VLC and FFmpeg.